Hello students, in this video we'll see how to use the convolution theorem to find the inverse Laplace transform of a product. Let's consider the inverse Laplace transform of 1 over s squared times s squared plus 1. We can write this Laplace transform inverse as the inverse Laplace transform of 1 over s squared times 1 over s squared plus 1. And we can use the fact that the inverse Laplace transform of the product of two functions is the convolution of those two functions. Now we know that this particular function, inverse Laplace transforms to t, and this particular function, inverse Laplace transforms to sine of t. So by the convolution theorem, the inverse Laplace transform of 1 over s squared plus 1 is going to be equal to the convolution of t and sine t, which is the integral from 0 to t of t minus s sine s ds, or the integral from 0 to t of s times the sine of t minus s ds. We can do either of these integrals, whichever one is easier. Let's focus on this first integral over here, first representation of the convolution. It will be equal to the integral from 0 to t of t times sine of s ds minus the integral from 0 to t of s sine s ds. Since this is a ds integration, I can take this t out of the integral. So t is constant in this expression. So the first integral becomes t, and then the antiderivative of sine is negative cosine of s from 0 to t. Then I have minus the integral from 0 to t of s sine s ds. So we'll simplify this first integral over here. So when I plug in t, I get t, and then negative cosine t, and then I'll have a plus 1 as my bottom limit, minus the integral from 0 to t of s sine of s ds. So I'll do integration by parts. I'll let this be my dv, and this be my u. So my expression will be t times 1 minus cosine of t, and then I'll have minus the expression. So I'll have u times v. So I will have a s times negative cosine of s from 0 to t. And then minus the integral from 0 to t of v, which is negative cosine, so that will turn to a positive cosine of s, du, which is just going to be in ds. So we'll simplify this. This will be t 1 minus cosine of t minus, when I plug in t over here, I'll get a t cosine of t with a negative sign. I plug in 0 to this, and I'll get a plus 0. So I'll get a minus t cosine t. Now, I will have this integral over here, the integral of cosine. That will give me an antiderivative of negative sine of s, positive sine of s, from 0 to t. And I'll just plug in the limits now. So I will have t times 1 minus cosine of t. And then I will have a minus negative t cosine t. And then I'll have a sine t minus sine of 0, which is nothing. And now we can simplify this. So when we simplify this, we will have a t, and then a minus t cosine t, a plus t cosine t, and then a minus sine t. Those will cancel out, and we'll be left with t minus sine t as our Laplace transform. So by using the convolution theorem, we're able to take a product of two functions and inverse Laplace transform them using the convolution of either one of those forms. Thank you very much.